Hi, everyone. Thanks for coming. My name is David Waldman. I'm the VP of Business Development for Stereolabs. We are a vision-based perception company. We're based out of, headquarters are in France, just outside of Paris. I'm based in California. This is my colleague, Pierre. We'll break this up a little bit. I'll give a general overview of the company and let Pierre dive a little bit deeper into the technology. Oh, sorry. Oh, big green button. Got it. Okay. So a little bit about the company. We work with Tier 1, Tier 2 OEMs to help them with their vision-based perception systems. We provide full stack of solutions from the cameras, which we manufacture. We have a line of primarily stereo vision cameras, as well as recently we've introduced some monocular cameras as well. To date, the company is about 13 years old, so we're not really a startup. We act like one. The company focuses largely in sort of two areas of customers, one on the robotics side, the other on the what we call digital twin, but customers who are using our vision systems on movable robots, so AMRs, tractors, anything that's out there that's looking at things like obstacle detection, object detection, localization, as well as we do quite a bit of work in the area of digital twins where people have fixed cameras in environments, so could be airports, could be warehouse, a lot of work with logistics companies as well. What we're seeing is sort of high growth in both of these sectors. These are driving our business forward. So on the robotics side, the agricultural sector is really moving forward, and we'll talk a little bit about that in a couple slides. But in terms of use cases, people use our vision solutions for a wide range of use cases. We'll touch on some of them, but core to those use cases are things like safety applications where you're doing object detection, a robot or a tractor is in the field and they want to identify something, or they're doing terrain mapping and they want to make sure that the leaves or grass are not a physical branch that they can't drive through. And all the way down to, people are using our cameras and solutions for immersive experiences as well. So, unique about Stereolabs is we provide a sort of end-to-end stack for a lot of the OEMs that we work with. So they will typically look at specific cameras that fit their use cases. Our cameras sort of range from these ruggedized IP-rated cameras that can withstand dusty environments, harsh weather that's required, as well as these monocular cameras, which maybe are a little less powerful, but still allow for tractors to have sort of a 360-degree fusion for their vision systems, where they want to see all around the tractor and maybe, for example, have a stereo camera in the front, a stereo camera in the back, and monocular cameras on the side for simple detection. We provide the SDK is something that's used by well over 100,000 developers sort of globally at this stage. Again, it's been around for many years and it's extremely well documented. So for engineers or anybody interested in sort of getting started with the Z perception system, it's a very efficient system for prototyping, for getting up and running, as well as supporting you in full deployment and scale as well. And then we also have a cloud platform which allows folks in, for example, logistics to monitor these cameras remotely as well. Yeah, so just a quick touch on some of the customers that we have. We have thousands of customers globally that use our cameras. We don't always know what all of them are doing with it. Ultimately, we sell the hardware. They have access to the SDKs, and they can sort of make use of it how they like. With many of the customers, we work very closely to support them, particularly as we get up into sort of Tier 1, Tier 2 OEMs. We'll work closely, like Monarch Tractor, who deployed our Z cameras in the front and the back. I think I forgot to mention that the cameras require a processing box. Here you can see the sort of reference being the ZX in the front and the back and the box on top. Just to mention, Monarch, if you're not familiar with, is one of the first fully autonomous electric tractors on the market, fully vision-based. We're happy to be partnering with them. And then Advanced Farm is another really impressive company. If you were at their event last night or some of the demos, this is a apple picking robot, fully autonomous, has 6 robot arms on the vehicle, 3 on each side. And I think some of the numbers that they were putting out is they were picking, over 40,000 apples per hour, and they're using our cameras on the actual actuators to look at depth of where the apples are, so that their robots can be able to reach out and pick them. So really impressive company. And just a high-level view about how we sort of look at the market right now. A lot of our customers are sort of looking at deploying autonomy or autonomous solutions either across tasks or operations. So they're working with our systems, across whether it's plowing, seeding, and specific applications there. And they're all leading towards this fully autonomous solution, but at least for the moment, what we're seeing is this really heavy focus on these specific applications to start, particularly around these particular use cases, but also, again, safety, being able to recognize objects in the field that would sort of be a danger to people or the tractor or to improve performance. And with that, I'm going to let Pierre talk a little bit more in detail about the actual technology stack.
Yeah, thank you, David. So here I will talk about the automation and what it means to have an AI perception system. So we identify 5 critical tasks to do to be able to perform outdoor with the robots. So the first is accuracy, what it means to have a robot outside. How do we measure its performance and its accuracy, because we want the robot to be able to do its job and to do it in the best way as possible. One of the challenge here is the uneven terrain, so we need to actually know the perfect geometry of the terrain to be able to see if the robot can move safely or if you will fall in a hole or stuff like this, which never happen in warehouses or more conventional surfaces. As David said, we also have some issues with what we call soft obstacles, like the geometry sometimes is not enough, so we can perceive something that looks high, like tall grass, but it's just grass, so you can move on. And in contrary, you will have some small object like irrigation pipes, and you can't go across it. So we have to understand what's the terrain and what are present in the scene. Another specific part to develop, to work on is regarding the weather and the dust. We should be able to work in most of the situation, like when it's raining, when it's foggy outside, and when we start working in a dry season like this, there's lots of dust, and as we are a vision-based system, we should be able to keep working even in those situations. So we train all our AI model to still work and perform on this condition, and to be able to have some alerts at some point saying, okay, the conditions are too degraded, I can't work anymore. And we focus also a lot on the compute power, because all those tasks require many computation, and as we want to use many cameras, everything needs to run in real time on small boxes with some small compute power. So it's a very, very challenging task. So for all these tasks, we created what we call Terra AI. So the goal is to be able to use as many cameras as the user wants or as it's required. We are moving from one camera for an application to a perception system, so it won't be one or two cameras. The goal is to abstract the number of cameras and the type of camera and just provide a perception system. If it requires 2 cameras or if it requires 4 or 8, the system will handle this for you, and at the end, the development will be the same for the developers. So, but as we had camera and we want to always add more neural network for complex tasks, we should keep the compute power as low as possible. So Terra AI is for multi-camera and multi-AI model to be able to have 3D, 360 degree perception stack and to fit any machines. For this, we have the full solution with many cameras on the same compute machine, and we have what we call surrounding view. So if we place 4 cameras on the same machine, we can see all around the vehicle and do some navigation and some detection, for instance, like this one, and be able to perceive someone's moving in front of the vehicle, and then as soon as the people is outside the trajectory of the vehicle, we can resume the movement. We also, we are a vision-based company, and so we want to focus on the comparison with the LiDAR, because the LiDAR is still very widely used. So we always compare us with the LiDAR. So with our latest neural depth mode for the depth sensing, we tends to have the same quality, but the thing is that as it's based on RGB images, we already have the image. So if you have a running detection model on the images and you want the depth or the position of the very specific, you don't have to use a calculation between one camera and the LiDAR. You will have directly the position of the object you detect in the depth map. And the thing is, we use the full image, and for every pixel you will have its 3D position. So we have something that is way more dense than the point cloud of LiDAR, and with the associated color. Our perception system also, like I said, should work in any weather or any dust condition, but we also want to make it work in low light condition. We still require some light at some point, but we want to make it very robust to this, and so that's also why we develop our own hardware to select some specific image sensor to work in low light condition and to have some great images even in dark environment. And we train our AI model to work as well on this condition, like this one also with the water drops on the lenses, which for typical basic depth sensing algorithm is an issue. Our model is trained to be robust to those conditions, and so it's no more an issue for us. That's it. And we see the sky can be a problem because it's a huge uniform surface. The water drops also, but with the depth sensing, we also have confidence information, so we know where the depth information, or at least the data we provide, are certain or uncertain. And so at some point the sensor itself can say, okay, I am no more confident, I will stop. And so the final user will be able to trigger some alert or handle this situation and not being in a state where it doesn't know what to do. To work on this and to have something efficient, we also work on simulation because, like I said, we want to train our model in very various conditions and in some very specific use case. So as we have customers working in many specific areas like vineyard, orchard, open field, many different things, it's really hard for us to get all the video, the real video. So we ask for few details and then we create everything in simulation. So we create the environment, it's very easy with the Stereolab simulator, and then we can parameterize everything. So the weather, the time of the day, if there is snow, fog, rains, the light condition, everything we need to make sure our algorithm will run smoothly in most of conditions. By default, the algorithm will be able to perform well in 80–90% of of the time, but what happened in the 10 or 20% remaining time? So this allows us to work on those specific use cases and to have very great result and to go beyond those limitations. So yeah, basic comparison also with the LiDAR. So with the multi-camera and all the camera, the different camera we have with wide lenses or narrow lenses, or the combination that we can have, we can see at the same distance with the same accuracy. We have way more points of measurement due to the high frequency of the image and the high resolution of the image. So, and we don't have. So yeah, it's very competitive with the LiDAR now, which was not the case a few years ago. But now with the improvement of either the image sensor and the neural network that we develop, the comparison now is best on our side. And we, like I said, we are a software company, but we want to focus also on the hardware part because we want to have a full control over the pipeline. So we want to develop our own sensor to have the very specific characteristic that we want. So now we have the Z1, the ZX line, and we are targeting to release in Q1 the ZX Pro line with the new HDR capacity for automotive grade sensor, which are great for outdoor environment because with the strong sunlight condition and the shadows associated, the HDR is very useful. And also this new sensor, the new Sony sensor with this automotive grade has a very wide vertical field of view. So with fewer camera, with just one camera, we'll see way beyond the current generation. So the coming version of the ZX Pro will be a huge step forward, and associated with the new development in our neural network, it will fill the gap and tackle many issues that we had before. So thank you, and come with it, and visit us. We're on booth.
We have
8.
about 5 to 6 minutes before our next presentation.
Yep.
We went a little over time, but we have some flex time, so go ahead and take it for Q&A.
Okay.
Sure.
Any questions?
Questions?
Okay. Yeah.
How does it work in like this, when there's practically zero visibility? Like in the thick fog that we have around here, are there any issues?
Yeah, so we train our model to work at best in those situations. So by visibility, do you mean just fog or no light
Just
at all?
thick fog.
In this condition, it's like if you can see it with your own eyes, the camera won't see it
Okay.
either. So it's almost the same.
Got it.
But as soon as you can see the shape of the object, the image, the camera will see it and perceive as well. So
Right. Thank you.
it's the same as the human eyes, basically. So we use standard RGB camera, no multispectral camera, because they can work on those situations, but they are very expensive at this time. So we don't want to increase the BOM cost, and we want to keep it simple and affordable to have some kind of this. But we are looking into it because at some point they will be cheaper than today, and we will integrate them at this time.
Thank you for the presentation. So my question is about the machine learning part. So is the training pipeline API open? Can we fine tune the model ourselves based on our data?
Yeah, it depends. So for the depth sensing algorithm, it's our own. So we train it with our own data, and we take care of it. So, and for some specific task, for example, fruit detection or vegetable identification, we create an API for you to run your own model within our SDK. So this way, you will be able to do your own detection and use it, combine it with our depth and our whole stack of tracking and everything. So yeah, it's variable in our SDK.
What sort of GNSS input do you accept? Are you agnostic? Do you have specified, like qualified suppliers, or are you just focused on pure GNSS outage all the time?
It's an agnostic system. So we have an API for this to combine it with our own positional tracking. So if the GNSS drop, it will continue with our own positional tracking, and it will fuse as soon as the GNSS came back. So we don't rely on a specific provider. So it's open.
Do you accept any external inertial input from like a higher grade INS?
Not at this point. We have one in the camera, and so it's used for orientation estimation, but it's not open at this time, but maybe later it will.
And do you do anything with radar at all?
Not at this time. We are looking into it for redundancy between the two sensors. We've met many partners and providers to build a camera with radar in it. So those are options that we were looking into, but at this time the radar are way far beyond, below what we expect. So at this time it could be useful at some point, but the results are too uncertain at some point. So not at the moment.
Thank you.
Anything to add?
Thanks, everyone. Come by our booth if you have any questions.
Thanks. Bye.